Okay, we are recording. Today is April 4th, and we are getting into database stuff now. If you don't have the Microsoft Access software, one, talk to me. Two, we have a way for you. We have multiple ways for you to get it, so don't worry. Okay, so with that, first thing is either come off mute real quick or throw something in the chat box for me. You know, when I say database, what does that mean to you? And I'm going to wait today until the answers. All right, yep, an area where you can enter data. I'll take that, right? Some kind of, actually, I really like that, keeping track of info. You folks are right on it, exactly. So the textbook definition, ooh, forms, good one, Rochelle, definitely. So the textbook definition of a database is a collection of related data. And yeah, so same thing, exactly what Iris was saying. I think we're all on the same page, which is awesome, right? So what is a database? It's some kind of collection of information. You're storing the data, you're defining it, you can sort it. It's very well organized, either with categories or filters. You can query it, which essentially means you can ask questions and find exactly the information you're looking for. And then you can also output the data, right? So you can have it go to a report, you can export it to Excel, you can automatically send an email. There's all sorts of ways to do it. And in terms of getting your data into a database, we'll talk more about that, but a lot of times you're going to want to use a form, right? So that way you are capturing the correct data and validating the data before you save it. All right, why should we use databases? Because it's a better way to manage it. You can reduce redundancy, which is storing the same information multiple places. Think about, I am not by nature an organized person. So if I'm keeping paper records, I'm going to have 5 different pieces of paper that all have the same thing written on them, because every time I go to look for it, I can't find it, right? That's just the way I work. If I use a database, some sort of central repository, I'm not going to have that redundancy anymore because it's being saved in one place and it's always going to be there when I look for it. Another big benefit is reducing data inconsistency. And here that means you're not going to have inappropriate data. I don't mean inappropriate like go to detention. I mean inappropriate like it's not something you need for that purpose. You're not going to have incomplete data. When you're using a form, like Rochelle told us, to get information into the database, the form can enforce, let's say it is an unemployment application, right? You're going out there, you can't go to work, you need to apply for unemployment. When you're submitting that form, it's going into a database. And what is that form going to do? It's going to make sure that the data you're submitting is complete, right? They need your name, they need to know where to put your money, they need to know how much money you need. The form is going to make sure that the data submitted is complete, and then it's also going to help prevent user error. So the form is going to know that if you're doing direct deposit, the routing number, the first part, I don't know the number off the top of my head, right? But it's going to be a fixed length number, right? It will always be let's say it's an 8-digit number. That's the routing number. If you try to put more or less, it's going to throw an error and say, hey, you put something wrong here, please correct it, and then the database will accept it. we have different types of database. What I think generally, when we think of databases, either from past classes or anything kind of past knowledge, you're going to be thinking of what's called a relational database. So that is structured data. That's your tables and rows. You have these concepts of relationships, of one-to-many, one-to-one, many-to-many. If you don't know what those three things are, don't worry. We are spending the next few weeks on databases, and we're going to dive in. And then we also have the concept of non-relational databases. What those are, think of your big data sorts of things, right? So it's unstructured data. So the relational database has tables, rows, columns, all of those things. That's the structure. A non-relational database does not have that structure, because the non-relational, the big data, it needs to be super fast. And what do you put in there? You put in what are called blob objects. That could be audio, it could be video, it could be pictures, large documents, anything that doesn't fit nicely, essentially, into a text field is going to be a blob. Let's talk about storing and defining information. One thing that was very important thing is right off the top, you're going to have metadata. And that is data that describes the data. A little bit weird, right? What's that mean? It's going to tell you what kind of data are you storing there, what are the properties, how big is it, what do you do with it, is there a default value, maybe there is some description, right? So the metadata is going to describe what is being stored there. We have a concept of a primary key and a foreign key, and those lead you to referential integrity. Getting a little bit buzzwordy today. Basically, a primary key is on any table. Say, let's use the example of an online store, right? You're going to have a table for all of your customers. Each customer is going to have an ID associated with them. So that ID is going to be unique to each customer, right? No two people are going to have the same ID. Elsa would be customer number 1, Sochi's customer number 2, Rochelle's customer number 3, right? That is a primary key. It's unique to each of them. Where a foreign key comes in is, okay, so we have our customer table that's storing all of the information about Elsa, all of the information about Sochi, right? The information about the people. Then we're also going to have an orders table saying, okay, Elsa came and bought 10 packs of toilet paper. Sochi came and bought all of the paper towels. And Rochelle bought 15 dozen eggs, right? So that's the order. We need a way to link the order table back to the customer table so that the database knows who ordered what, right? So you take that same ID of, okay, Elsa is customer number 1, and you put that over to the orders table, and then it becomes a foreign key because it's referring back to something else. If that confused you, it's okay. We have another section all about that. Other things that go into storing and defining data are input forms. We talked about that just a minute ago, right? Making sure that what is being entered by users into the database is done properly. Being done properly is referred to as data validation. That can take several different forms, a range check, a completeness check, which essentially means, is this required? Think about when you had to fill out that form for me about your access to technology at home, right? I made it so that every single question on there was required. If you tried to skip something and submit it, it said, hey, go back and answer that question, right? There can also be a consistency check and a alphabetic / numeric check, which you may have noticed I did have an alphabetic check on the email address on that same form where I was asking about your access to technology. If you tried to enter an email that was not your Maricopa email, I had data validation there that would only accept an email address that ended in @maricopa.edu. If you tried to enter anything else, it did not allow you to submit that form until you put in the email address that matched the alphabetic check on the data validation. And think about that from my perspective. Why did I do that? Because I am going to take what's in that form and the people that need access to technology, we'll talk more about exactly how it works, but I'm going to give them the tools they need. And the most important thing is that I have a way to communicate. So I wanted to make sure that I have your direct Maricopa email address, right? Because if I don't have your email address, how can I give you what you need? All right, these are the sorts of things that I find funny. So let's take a minute to read this comic and tell me what little Bobby Tables is doing. I don't expect everyone to get this. It is a pretty big jump from what we were just talking about. But there are no wrong answers. And if you throw it in the chat box, it won't be part of the recording. So at least give me a guess. Bingo, we got it right there in the chat box. So what's going on here is this is called a SQL injection attack. And this shows why data validation is so important. So just to geek out on this for a minute. So this right here, right, where it says the name is Robert, all of these little special characters with the single quote, the end parentheses, and the semicolon, those are SQL, when you're doing databases, it's all programming, right? So there is a language with defined syntax that says how things work. And then here it says the name of the kid is Robert, drop table, students, all of this other special stuff around it, right? So what does that do? Well, if your form is not properly validating the inputs, it's going to take exactly what is typed in and pass it right to the database. Now, this drop table, in database language, that means delete the whole table. So what happened here is because this went in as drop table students, well, all of the student records are lost, And what does the mom say? Well, you should have learned to sanitize your inputs. These are the things that I find funny. All right. So queries, we mentioned this a little bit. What are queries? Query is essentially a super powerful filter. You can use them on just one table, or you can use them across multiple tables. And very importantly, you can save them for later use. So let's think that maybe you are in the South Mountain Community College registration office, right? Of course, all the classes everybody signs up for, that goes into a database. If you want to look at that database and figure out who is in each class, you have to write a query. If you're looking at the same information over and over again, right, maybe you have to, on a weekly basis, check the enrollment, you want to save that query so you don't have to write it again every time. So you can save the query, come back to it, and next time just say, go. You don't have to do all the work again. And then we can also get more complex, right? So you can go to multiple tables. You can say, all right, I want to know the enrollment in each class, and then I also want to have contact information for each student. So the enrollment information will be stored in one table, and the contact information will be stored in a different table. One query can join those two tables together and pull out the information that you need. If that's not complex enough for you, you can go into SQL, which is structured query language. These are programmatic queries, right? So here we are using relational algebra. Sounds scary, but really most of that is going to be equals, greater, less than. That's about, for the most part, as complex as it gets. And then you are using, again, in structured query language, you're using things called queries, right? So you have a select query when you're looking just at one table, and you have a join query when you're looking at multiple tables. All right, it is now time for terminology bingo. And I'll be nice. So data is your raw facts, the numbers entered in the computer. It might not mean anything to you as a person, right? It's just data, just numbers. A field or column is a name, a number, something that describes one aspect of an object. So if we have the student contact information table, right? One field will be first name, another field is last name, another field is email address, another field is phone number, right? Each one of those describe one aspect of a student, and in this case, the object there is you as a student. So that's going up and down, right? That's your columns. A row, a record, is a collection of fields going across. So a row is going to be using, well, Rob's the last one in the chat there, right? So a row is going to be Rob's name, Rob's email, Rob's phone number, right? All going across this way. A table then is a collection of records, right? So for this class, we have 18 students. So there would be 18 rows in the CIS 105 students table. And then a database is a collection of tables. So there's going to be one table for each class. You roll all of those up together and you get a database. some more terminology bingo. Database versus instance is a bit esoteric. And then DBMS and DBA. So a database, we just talked about, is a collection of tables. An instance is a copy of the database running in memory. That's kind of hard to wrap your head around. Think about it if it is a very large organization, right? They're going to have multiple databases, and maybe they have one really big server that runs all of those databases. So an instance is going to be a copy of the database running in memory, meaning it's currently being used. DBMS is the database management system. That's software that allows us as users to go in and create and use a database. So for this class, the database management system that we'll be using is Microsoft Access. In my professional life, I work very heavily with Oracle and SQL Server as different database management systems. Database administrator, that's me. And that will be you as this class goes on, right? So that's the person who creates the database, installs the software, configures it, and manages the database. They administer the database itself. That is I'm not going to say it's a fun job, but it's a very good job because not a lot of people like to do it. And then thankfully in the technology/software world, when not a lot of people like to do it, that means it makes a lot of money. So if what we're talking about for the next couple weeks is at all interesting to you, then I recommend looking into seeing if you can move your way into being a database administrator. Very secure and safe line of work. Because once you know how to do it, people will say, oh, please come do this for me so I don't have to do it. All right, a little bit more terminology bingo. Table, we have already discussed, right? So that's where you store your data. A query is how you search the database to find specific answers. We talked about a query as looking for information. Also know that queries are how you update the data. So you have a select query, which is going to search for data, and then you have an update query, which is going to update the data, and you have a delete query, which is going to delete some data. A form is used to input your data cleanly, right? We talked about the input validation, making sure you're getting all of the information that you need, and in the example of an email address, that it's the right email address. I don't want your personal email, I want your school email. A form can make sure that the data is being input correctly. On the flip side is a report, right? So you use your query to find the data that you want, and then you can use a report to analyze or present that data. So instead of just having the raw information coming back out of the database, you can put it into a report and make it look nicer. And then primary key, we also discussed, right? That's the unique identifier, some code to identify a single record. All right, future of databases. We have, I don't know if we have any old head basketball people in here. So over on this right side, this is Allen Iverson, and he went by the name of AI. In the database technology context, when I'm saying AI, what does that mean? I'll wait.
artificial intelligence?
Artificial intelligence, bingo. So that is your Siri, that's your OK Google, right? All of those digital assistants, that is artificial intelligence. And then that leads into the Internet of Things and big data. So Internet of Things is all of those devices connected to the internet that don't necessarily need to be connected to the internet, right? So maybe you have a smart fridge or a smart coffee maker, right? Anything like that. If it's some kind of device that's connected to the internet, then it becomes an Internet of Things device, right? It's not your traditional computer or laptop or phone. It's just some appliance, something that is connected to the internet. And then big data, we talked about the non-relational. There is an extra credit assignment on Canvas that I very, very, very highly encourage you to read that article and do the discussion. So big data can be super useful, right? Think about right now, we have this pandemic going on, and we have all of these people in the hospital and all of the doctors trying different treatments to figure out what is working to help people, right? What big data can do is take all of that information. So you ask the doctors to go put it in a database, right? Say, okay, I have this patient, I gave them this medicine, and 2 days later, they started to feel better, right? So think about how many hundreds of thousands of people around the world we have in the hospital right now, all with this same disease. If all of the doctors trying all of their different treatments are able to aggregate that information in one place, then you can start to look for trends, right? So what works for one person doesn't really tell you much. But if you find that around the world, maybe this thing is effective 20% of the time, now let's start looking into it. Why does it work? How can we dig deeper? Maybe did those people all have some common characteristic about them that allowed that treatment to work? So big data allows you to take all kinds of things, mash them up, and get useful information out of it. That is a really awesome, good use of big data. Unfortunately, we also have maybe not so good uses of big data. So the extra credit article, the extra credit discussion board, what the article there is talking about is the 2016 election. Maybe you've heard of Cambridge Analytica. If you haven't, you will, where essentially they were able to go and use people's Facebook pages to get information about them and then very specifically target them with advertisements about the election. It is frankly scary how accurate they are able to get and how much of an impact they were able to make. Now, when I say accurate, I don't have it in front of me, but when you're reading the article, you'll see it was just by looking at the pages you like on Facebook, the comments you like, what posts you comment on, right? Just looking at stuff like that. I think it was if they get 30 of those are called data points, right? Every time you hit like on something, that's a data point. By taking 30 of those, applying all of their big data stuff to it, they were essentially able to tell with 80-90% accuracy if you're black, white, Republican, gay, straight, just by looking at what you interact with on Facebook. You didn't tell them directly anything about you. They just looked at your behavior and were able to deduce it. I really recommend reading that article just to see what's happening. And then I hope that we can have a really a cool discussion about it. And we may even turn that into a classroom discussion. So yeah, I'm with you. It's crazy. It blew my mind the first time I read this article. I think it's a really important thing for us to realize what's going on. Okay, we know the good uses of big data. We know the bad uses of big data. How do we regulate what's going on so we can get the good without having to deal with too much of the bad? All right. Some housekeeping items, and then we will go into an access demo. And then after the access demo, we will do what will we do? We'll do some, if you need help getting the Microsoft Access software, I'll show you how to do that, but I don't want that to be part of the main recording. So main recording housekeeping items, we have that big data extra credit assignment we talked about. That is on Canvas as a discussion. Highly recommend you do it. It's worth up to 50 points. And then I also just think in terms of life, reading that article is a very good thing to be aware of. Class has been extended until May 23rd. I still want to stay on track. Let's aim for having everything wrapped up by May 8th. So try to stick to those due dates that are in Canvas, but know everything is flexible, right? I understand life is way out there for everybody right now. There's all kinds of stuff going on. So let's try to keep with our due dates on Canvas, but I'm not going to be sticking to my, if you're 1 day late, it's 50% off. If you're over a week late, you're not getting credit. That's out the window, right? I'm going to work with you. We're going to be flexible. The hard deadline is that class ends on May 23rd. Try to keep on track. Try to do it week by week. I understand stuff is happening. We have that's why I'm recording the classes. You can go back and do it at your own time, but I very, very, very highly recommend trying to stick to the schedule. The extension happened just because there's been so much going on even within the college, where I know there are people that think that this class doesn't actually start up again until Monday, right? So they haven't been here with us for the past couple of weeks. They're going to come in, log into Canvas on Monday and go, oh no, right? And then even everybody who has been here, I know for myself, life is throwing all kinds of curveballs at us. So let's work together. We have more time. We're going to get there together. Speaking of getting there together, access to technology. For the rest of this class, we need to be working with Microsoft Access. If you don't have a Windows computer, we have ways to help you. An online computer lab where you can use any computer, a phone, a tablet, whatever you have. You can use that to access the online computer lab. And the online computer lab is just like what's on campus. It has all of the software installed, and you just log in and you use it. If you have a Windows computer, but you don't have the software installed, the software is available for free from the college. So if you have a Windows computer, but you don't have the software, I can help you for free install the software on your computer. If you don't have a Windows computer, you're not going to get the software, and we have a virtual online computer lab that you can access. If you need either of those things, talk to me directly, and I'll help you through it. And I will also, later on today, we'll do a video showing how to do both of those different ways of accessing the technology that you need. So I don't know what's going on in the summer courses. If I have information about that, I'll let you know. I do have some information about advising that I'll share out by email. You know, it's all fluid. I don't know what's going on in the summer, but I do know that for this class, we have an extra 2 weeks to work on stuff. All right, so we are at 12:11 now. I am going to stop recording, but we still have more to go. We have an Access Live demo part. So think about when we were doing some of the complicated stuff in Excel when we were in class, right? We did that together where I showed you step by step. We're going to do that with Access today, but I want to take a break. I want to give you a break. So I'm going to stop recording now, and we will start back up at 12:30 with the next part. Stopping recording. Please do not leave the classroom. You can walk away from it, but keep the connection open. I'm going to leave the room open. I'm going to leave the chat box open, but I'm going to stop recording and go take a break myself, and we will restart at 12:30.